have to get one of those cool little things. So right now we're going to be talking about complex numbers. And this is just it's a combination of real numbers and imaginary numbers. And you're always going to see complex numbers in the form of a plus bi. A is your real component. B is the coefficient to the imaginary component. Okay? So where it says where A represents the real part of the number, and we talked about what real numbers were earlier, and bi represents the imaginary part of the number. So whenever you have it together like that, it's called a complex number. All right? If A equaled 0, and basically A wasn't there, then the number is considered a pure imaginary number. Okay? So when you dream at night, if there's no A part, if there's nothing real, it's pure imaginary. Pure imagination. Who does that? Willy Wonka? Okay. So BI is your Willy Wonka. If B equals 0 and you don't have an I component, then that's just a real number. Okay? And those are all the numbers you've dealt with up to this point. Okay? Now, if you have two complex numbers, let's say they're A plus BI and C plus DI. Okay? These puppies are equal if A equals C and B equals D. All right? If the real components are identical and your imaginary coefficients are identical, then your two complex numbers are equal. All right? Have y'all done, well, never mind, I won't even go there.
Oh, wouldn't it be BI equals DI?
It would actually just be equals D, because I is the same. I is still square root of -1.
Well, what if it's I squared or something?
Then it's not the same.
Okay.
Because I squared, if you have I squared, that equals -1 automatically, right? So there's no I part of the number left.
Oh, okay.
There's no imaginary
Makes
part.
sense now.
And so we're dealing with just complex here. No, excellent question. All right,
And if
let's
it's
go
like
ahead.
I cubed, so it's negative I, the negative would be part of the coefficient anyway. So.
Yep, so it's always going to look like an I. Very good reasoning. All right, so we got 2 minus xi equals y plus 5i. So we have a complex number equals a complex number, and we want to solve for x and y. So the first thing you do is you say, okay, I want to set my, remember, complex numbers are in the form of a plus bi. So first thing we want to do is look at our real components and set them equal. Okay, so my real component here would be the 2, my real component here would be the y, so guess what? 2 equals y. No biggie, right?
Wow. So we have one of them already.
You've got one of them already, it's just straight up.
Nice.
Okay, now the other one, remember we said A, what was the other one? C plus DI, and A equals B, and, or excuse me, A equals C, and B equals D. So now we want to look at the imaginary part. Here we
So
have a
we do negative xi equals
and
5i.
Right, and you could just say plus negative here if you wanted to, because when you're looking at the complex number, it's got the plus in the middle. So just so we're doing it right, so I would say negative x equals 5. Well, that doesn't tell me what x is, it tells me what negative x is. So I'm going to go ahead and divide both sides by -1 or multiply. So I get x equals -5. So we solved that. That's not hard. Good to go? All right, now we're going to learn how to add and subtract them. Whenever we find numbers, we always learn how to add, subtract, multiply, and divide them. You've done it since the beginning of time. And that's what we're going to do with complex numbers. So let's add, subtract, multiply, divide these puppies. First example, 2 minus 7i, close parenthesis, plus -3 plus 5i. Now, this is really just like adding polynomials in the sense that you add
Combining
like
like
terms. Perfect. So real term here, that's going to leave me with -1. So far, so good? And then, let's see, real or imaginary term here, what's that going to be, minus
Negative
2i? Minus 2i, or you can write it as -1 plus -2i. Typically, you'll see it written with the subtraction just because mathematicians like to use less symbols.
Yeah.
Right, this gives me down one symbol than this. But technically, this is probably better with the a plus bi, but this is totally acceptable.
Okay.
All right, let's look at our next one. Let's do the subtraction. 2, what is that, minus 7i? And it's take away -3 plus 5i. Now, the big thing here is when you start subtracting, remember that this complex number is a whole number. And so that's why they put it in parentheses for you, because you have to subtract the whole thing. You have to subtract this real component from this real component and this imaginary component from this imaginary component.
So, are you going to change it to
Adding the
addition?
opposite?
Yeah.
Sure.
Okay.
I mean, that's a good way to do it. Add the opposite. So that's going to become 5 minus 12i, looks like to me. Okay, so you're totally good there?
Yep.
Okay. Can I